Welcome to tonight's video. We're just practicing more on concavity. This time we're going to deal with a lot of trig functions. So remember, concavity is second derivative. So first derivative here is 7 plus. Now 2 over sine x. Remember, that's the same as 2 cosecant x. And the derivative of cosecant is negative cosecant cotangent. So really it's negative 2 cosecant x cotangent x. If we simplify that into sine and cosine, right? Negative 2 cosecant cotangent is the same as 2 over cosine over sine squared. So we can do the quotient rule here. So we have u equals 2 cosine x. So when we do double derivatives, we have u equals 2 cosine x, u prime equals negative 2 sine x. The denominator is sine squared. The derivative of that is 2 sine x cosine x using the chain rule. So when we do the double derivative, the negative stays here. So remember, it's u prime v, so it's negative 2 sine to the third x minus, and then u v prime, so it's 4 cosine squared sine x, and that's all over sine squared squared, which is sine to the fourth. Then notice here when we distribute the negative sign, it becomes 2 sine to the third plus 4 cosine squared sine x all over sine to the fourth. And if you take out double prime, take out a sine x and a 2, you have 2 sine x. So you have sine squared plus 2 cosine squared all over sine to the fourth. This cancels out here. So technically you have 2 sine squared plus 4 cosine squared, and that over sine to the third. So remember, for concavity, you want to know where the double derivative would make it equal to 0 or undefined. Well, with fractions, you have to ask yourself, can 2 sine squared plus 4 cosine squared equal 0? And understand that if you're squaring the cosine and sine and adding them together, you will never get 0. You'll always get a positive number. So here, this does not exist. Sine to the third equals 0. Well, that is when basically between negative pi and pi, that's when x equals 0, right? It would be 0 pi or negative pi, but 0 is the only one between that interval. So the only critical number here is 0, negative pi and pi. So now we're going to pick pi over 2, sorry, negative pi over 2 and positive pi over 2 to go between these intervals. When you put that number in the derivative, the double derivative, notice 2 times the sine of negative pi over 2 squared plus 4 times the cosine of negative pi over 2 squared over basically the sine of negative pi over 2 to the third. Well, the sine of negative pi over 2 is negative 1. Right, squared is positive 1, so this would be 2 plus 0 over, this would be negative 2, so it would basically be negative. When it's positive pi over 2, that makes the bottom positive here. So therefore, the function is concave up from 0 to pi, and f of x is concave down from negative pi to 0. Alright, the next one says find the point of inflection. And the point of inflection, remember, is where the double derivative is equal to 0. So we have, Alright, so the derivative here, remember the derivative of cosecant is negative cosecant cotangent, but with the product, or with the chain rule, we'll say u is 3x over 2, which means that u prime is 3 halves. So remember, this would be negative cosecant u cotangent u times u prime. So it's basically negative 14 cosecant 3x over 2 cotangent 3x over 2, that's the angle, times 3 halves. So 3 halves times 14 gives you negative 21 cosecant 3x over 2 cotangent 3x over 2. So now we have to take the double derivative, the second derivative. So we have to take derivative of that. So this is where we get we could do a product rule, right? So u would equal cosecant 3x over 2. U prime is negative cosecant 3x over 2 cotangent 3x over 2. And the v would be cotangent 3x over 2. And the derivative of cotangent is negative cosecant squared times 3 halves. It would be the same thing here. I'd have to do this times 3 halves. So it would be negative, it would actually be negative 3 halves cosecant 3x over 2 cotangent 3x over 2. And here it would be negative 3 halves cosecant 3x over 2 squared. Remember the quotient rule, the product rule, it would be, we're going to multiply this negative 21 times. So we go u v prime, so basically it'd be negative negative 3 halves cosecant to the third power of 3x over 2 plus, and then we go u prime v, so it'd be negative 3 halves times cosecant 3x over 2 cotangent squared 3x over 2. And then when we multiply right? When we multiply by negative 21, we get 63 over 2 cosecant to the third, 3x over 2, plus 63 over 2 cosecant 3x over 2 cotangent squared 3x over 2. Now, if we turn everything in terms of sine and cosine, right, this would be 63 over 2 sine to the third 3x over 2 plus, and then this would be 63 cosine squared 3x over 2 over, and then this would be sine times sine squared, so sine to the, over 2 sine to the third 3x over 2. So notice you could combine because you have a common denominator, so it would be 63 plus 63 cosine squared 3x over 2 over 2 sine to the third 3x over 2. So that's the second derivative, and if you basically set them equal to 0, both the top and the bottom, right? So 0 plus equals 63 plus 63 cosine squared 3x over 2. You get negative 63 equals 63 cosine squared 3x over 2. When you divide by 63, you get negative 1 equals cosine squared. And notice that cosine squared can never equal negative 1. So here, there's no real solution. Now, if you take 2 sine to the third of 3x over 2 and set that equal to 0, you would get that sine equals sine to the third equals 0. So that means 3x over 2 would equal 0, which means 3x over, or sine 3x over 2 would equal 0, which means 3x over 2 would equal, if you're talking about an interval between 0 and 2 pi, it would have to equal 0 or 2 pi, which neither one are in the interval. So therefore, this doesn't exist as well, which means there are no points of inflection. Because it only makes it undefined here at 0 and 2 pi, and 0 and 2 pi are not in the interval. Notice they're not part of the interval, so therefore there are no points of inflection that exist for this function. All right, last one. It says find the points of inflection for 7 sine x plus 7 cosine x. So let's take the derivative here and get, now notice here 0 and 2 pi both exist in the interval, whereas the previous one it did not. So this would be 7 cosine x minus 7 sine x, because the derivative of cosine is negative sine. Then when you take the second derivative, you get negative 7 sine x minus 7 cosine x. So when you set the second derivative equal to 0, you get negative 7 times sine x plus cosine x equals 0. So basically 0 equals sine x plus cosine x. And you want to know, where does the sine x equal the negative cosine x? And that occurs when x is equal to 3 pi over 4 and 11 pi over 4. Actually, sorry, 7 pi over 4. Because that's in the second and fourth quadrants, right? Because at pi over 4, that's where, sine pi over 4 is equal to square root of 2 over 2. Cosine pi over 4 is square root of 2 over 2. So they're the opposite in the second quadrant and the fourth quadrant. So there are the 2 points of intersection for the x's. Now to find the actual point, we put the 3 pi over 4 back in, right? 7 times sine 3 pi over 4 plus 7 times cosine 3 pi over 4. Well, this would be 7 square root of 2 over 2, but this would be negative square root of 2 over 2, so minus 7 square root of 2 over 2. So basically it's equal to 0. And when you put 7 pi over 4 in, it gives you the same thing. So the points of inflection are 3 pi over 4 and 0, and 7 pi over 4 and 0. Alright, that concludes our video for this evening. Make sure you do the web sign, and any questions, please feel free to ask. Have a good evening.